In this episode, we're going to be doing the final digging into this motor. We're going to check the bearing clearances and the bearings for condition, both connecting rods and main bearings. We are also going to be pulling the pistons and the crankshaft and the back cover. We'll remove the windage tray. These are all 13 millimeter. There is a front and a back to the windage tray. The rear is actually marked, so it looks like we have a set of Gen 3 rods here. Now with the windage tray off, we're going to pull the caps off of one of the pistons so we can check the bearings. You need to have a torque wrench when you put these back on because they do need to be torqued. We're just going to pull them so we can check the condition of the bearings. In this case, I'm D, and this is D-Mod's Garage. So in this case, the bearings look really good. There's no heavy scarring. There's a slight dullness to them, but it's not really bad. The bearing surfaces also feel really good. What you can do is you can take your nail and drag your nail across it. If you can feel stuff, it needs to be replaced. These also need to go back on the same way they came off, because if you put them on backwards, there's a chance that the machining process wasn't totally square, because they are set or machined while the piece is together. In this case, we're just going to snug them up. Next, we'll pull one of the main caps. I prefer to pull the center main cap because it has the thrust bearings in it, and this way you can check to see what the condition is there. So unfortunately, to pull the mains on these, there are 3 different sizes. The outside bolts are 10 millimeters. You need to pull those. All this stuff, when it goes back together, all needs to get torqued. You need to make sure you have a torque wrench and the specs, because they have to be set to a certain amount of pressure. They're slightly disformed from the amount of pressure, and it keeps everything tight, and you don't have to worry about things loosening up. The outside bolts are 15 millimeter, the inside bolts are 13 millimeter. This is another thing, the fact that these main caps need to go back in the same direction they came out. They are machined as one unit, and if you don't, there's a chance that there'll be an offset and it may cause problems. So in this case, the bearing also seems to be really good. It's a little bit on the shiny side still. You can kind of feel the grooves in it when you run your nail across it, but there's not too much discoloration on the main. If you look, there is a slight flat spot or dull spot on it, but other than that, it seems good. There's not too much wear on the end play cap, so looks pretty good. Okay, so in this case, we're going to go a little farther and we're going to start disassembling the motor. So just in case your motor isn't as good as this one, I'm going to show you how it's done. What we're going to do is we're going to mark each connecting rod. It's just a small punch. When I do them, I tend to set them up so the dots are the same as they'd be on a set of dice. Granted, that only gives you 1 through 6. Next, we're going to start pulling connecting rods and the pistons. So all we're going to do, I'm going to bring it up so we can get to the bolts real easy. An 11 millimeter. When I take the caps off, I always make sure that if I'm going to put them down, which side is facing forward on these. The flat side faces the flat side. But you can just put them down like that. Things should slide out real easy. I'm just using a wooden dowel to support it. I'm sliding it out. I'm holding the piston on the other side as I do it. Out it comes. Put it right back on where it came from, snug it down, put it in the box. They don't need to be super tight. You get, on the original rod bolts, they're supposedly good for 3 passes, or 3 times. You can torque them. The other thing is the piston will always tell you which way is forward. There's a dot on the top of the piston at the front, and that goes forward on the motors. Pull this one out. Depending how tight these are, like that one, the bearing didn't come off with it. Then just come peel it up and put it back on. You want to keep the bearings with connecting rod. So keep the connecting rods together. Once again, just push it out and it's out. So one way you can tell these are Gen 3 rods is there's no retainer there. These were Gen 4 rods. There would be a clip that holds them in, and there's also a bump on them that sticks out on the one side of the rod. You got to be careful not to nick the bearing surfaces on your crank. Be careful about dragging these things up the sidewalls. You ever wondered how loose you want a bottom end? When it's built, it's about like that. It's actually a little tighter, but. So the next thing we're gonna do is we'll take off the flywheel and then the back cover. It's these 6 bolts. Stick a screwdriver between the flywheel, the engine hoist, and the block. Just lock it in place. I'm just gonna give a couple of turns just to make sure they're loose. And move on to the next one. You're just initially trying to break them loose, not take them all the way out. And that's all of them. And then we'll just pull them out. Now to take this off, you just kind of keep pressure on and kind of wiggle it. You should be able to slide it out depending on your engine hoist. So the next is you're going to want to take off this back cover. It's going to be a little tight because of the fact that the engine hoist or the engine stand is right there. Once you get the screws out, just take a small pry bar. Just got to give it a quick little wiggle. It'll pop right off. And you sneak it out. And that plate's off. Next thing to do is remove the main caps. And so there's a 10mm on the outside. If you're going to take them all off, might as well just loosen them all. I'm just giving them a quarter turn to make sure they're broken loose. The outside one's loose. Those are 15s and the insides are 13s. And I keep the bolts with the caps. These are another one that are technically reusable 3 times before they stretch. What I'll usually do is if I'm going to do that, I'll reuse these to set my clearances and then I'll just use a new set when I'm ready. Do all my final assembly, I'll use all new ones. Do stick pretty good sometimes. Sometimes you do need to get a pry bar and just pry at them, just to kind of work them loose. Make sure you have the 2 bolts out of the side, otherwise you'll be fighting them. So your bolts are all the way out. Once I get them out, I throw the 2 side bolts back into them, and these need to go in the same exact place they came from, but they're already numbered from the factory, and there's only one direction they'll go in. The tangs on them, tangs here, all go facing towards the back, except for the back one, which actually faces forward. Now I'm going to turn this just ever so slightly because I'm taking the last bolt out of it. Next thing to do is lift out the crank. So this is the reluctor wheel, the back of the crank, and this is how it knows, the computer knows where it is when it spins. There's a sensor that goes in from the side right there, which would be on the passenger side, and it reads these little teeth and the high marks. So when I was editing this, I noticed that the video that I shot for this came out really bad. So I'm reshooting it, so it'll explain a little bit better how this works. So this is Plastigauge. This is used for, you can use it to measure clearances that are a squash clearance. A squash clearance? Squash clearance. When you go into a place, sometimes you'll ask, and if it's a younger guy, he'll look like a deer in the headlights, and you'll have to find an older guy who'll go, oh yeah, we've got him over on the shelf, which is actually what happened to me. Or you can just order the stuff online and then not have to deal with all that headache. So all we're gonna do is there's a thin little piece of plastic wire in here. So all you do is open up the end a little bit and it'll slide out. You need a pair of scissors to cut it. You just need enough to fit over where the bearing is going to go. And sometimes these come out better than others.
So why is it called a squash gauge?
Because it's a known diameter, and as you squash it, it'll change shape, and then you measure the thickness after it's squashed out, and that'll tell you what your bearing clearances are.
It'd be a lot easier if you held it still so I could zoom in for them. So it's a green wire.
Yeah, it's just a little green piece of plastic, right? So whichever clearance you're going to check, just take a lint-free rag and just wipe it clean, because you don't want any oil in it. Figure out about how much Plastigauge you need to reach all the way across, and then clip it off. Different colored Plastigauge has different thicknesses for measuring. So you'll have to know what your clearances are going to be so you can get the right Plastigauge. I'm going to put it right across where the bearing surfaces are, and you'll set it down. Now the key is when you do this, don't rotate the motor. Wipe your clamshell, make sure there's no oil, because that'll change the clearances, and it will affect how the Plastigauge works, because you're dealing in very small, very small clearances. Put the journal down, and then you have to torque it like it tells you to your spec. So it's 15 foot-pounds, or all 4 of these bolts too. And then you have to have an angle gauge to properly set the torque on these, which I'll show you how to use. I usually just finger snug them down real quick, and I'll use the torque wrench. So like I said, 15 until you hear the torque wrench go click, unless you have a super cool digital one, and then it'll go beep, 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 and little lights will flash, and all kinds of other crazy cool stuff. And remember, don't leave your torque wrenches loaded. Make sure you zero them out when you're not using them, especially for any extended period of time.
Why?
Because it'll cause the mechanisms to not work properly.
Is that true on digital as well? Because you turn them off, I think.
Yeah, but the digital ones work totally different.
Okay.
And like I said, 15 foot-pounds really isn't much. It's barely snugged. Okay, so this is an angle gauge. And it's got a leg that comes down, and that has to sit up solid against something. And then you're going to turn this after you torque it. The inside bolts are 80 degrees. The outside bolts are 51 degrees. So it's got a socket to an adapter just to get it up high enough for me. This will go in.
So your direction is set by that post that's on it. I think you called it a leg.
Yeah, it holds it steady.
So that's how you know which direction to put it and how to put it.
All that leg does is just sits up against something. Only part of this will turn. So if you look, there's a gauge on it. As you turn it, that dial indicator will move.
Okay.
And then it'll move to, wherever you stop at. So all we're going to do is turn this one to, like I said, 80 degrees.
So when I go to put that down, does it matter where the leg is, what direction it's in at all? No, because as long as you have the gauge set to 0 and that leg is tight up against something, because what it is, that leg holds the inner ring in place, and then the top ring moves as you turn it, so this way you know how far you've turned it, because you have to turn, instead of actually using a torque, they use it by an angle. Okay.
And these things can be a little bit fussy from time to time.
Oh, I can see it moving.
Yep. You want to keep good steady pressure on it. You don't want to do jerky. And that's 80. And we'll do the other one. Just got to get reset to 0. And same thing. It's 80. And we'll swap out and we'll do the outside ones. Those go to 51 degrees.
When did they start doing this, roughly?
Actually, I know like the Iron Dukes, so mid-80s, they had what's known as an Iron Duke. It's a 4-cylinder 2.5. It was pretty much half of a 350. And the cylinder head bolts on that, you set them with a torque wrench, and then you had to go and like the center two you had to set to 90 or 120, and then the next one's out you had to set to 90, and you didn't move the. It was a really weird thing, and I've never liked it, just because it's just a weird.
It was, always.
Yeah, it was. It always just seemed like a weird thing to me, and I've looked it up, and I've never gotten a really satisfying answer of why they've gone to this. Okay, so we got.
So you say 80s, not 50s.
Yeah, this is 51.
No, not the number for your dial. I know you're doing 51 degrees. I meant like we didn't do this in the 1950s.
No, you use the torque wrench.
Are there different calibers of these gauges? Like, can you get a digital?
Probably. Well, on a lot of the new digital torque wrenches and stuff, they've actually got the feature built right into the torque. On a good torque wrench, it's actually got, so you can set it, so you can say, you know, and you can set how much you have to turn it. And it works just like you do on a, you know, the torque does, where it's got the little lighted bars and stuff on it.
Yeah, they're nice to use. So is that a hard to turn?
No, it's not super hard, but you know, I've got
a breaker bar on it.
18 inches of breaker bar. So those technically have been torqued down now. So now what you do is take them back off. Yes, these generally won't pop because they haven't set. You know, they're tight and they're torqued like they're supposed to be, but they haven't had a heat stress put through them.
How many sockets has he got in his pockets? Oh, the socket.
Is that a socket in your pocket? You're just happy to see me. It's a socket. Thank you. So.
Hey, I saw this in another video.
No, same video.
Okay, I pre-watched this video and I saw this earlier.
Okay. So what I like to do, so this way I have a very accurate measurement and is cut a section of it off. So this way you're not fighting with it nearly as much. Now all you're going to do is you're going to take this and you're going to size up how wide it is. So like if you look, there's little, so each one of those is a different measurement. That's 10 thousandths of an inch, 15 thousandths of an inch, 20 thousandths of an inch, 30 thousandths of an inch. And that's your clearances. So it's somewhere between 15 thousandths and 20 thousandths of an inch. So technically these bearings actually have, there's a lot of clearance left on these, or you know, you could run these for a while, depending on what you're going to do with it. Since I know that I'm going to beat this motor on a regular basis, like it owes me money, I'm going to loosen up the clearances a little bit more, and I'll put new bearings and polish everything, because like I said, this thing's going to get hammered on a regular basis. What'll happen is if you open, as that motor's spinning, the more horsepower you're making, the crank actually flexes. So the more horsepower you make, to a point, and I'll get on to this later, you know, how far you should have your clearances once I show you how to set your clearances, and we're putting the motor back together. But the more horsepower you make, the more that thing's going to flex. So you open up the clearances a little bit more, because A, you have to have that clearance there, because it's actually floating on a skim of oil. So it'll oscillate a little bit. The whole thing oscillates. So what happens is you need to open up those clearances just a little bit, so as it oscillates, it's not banging into the bearings. But like I said, that's how you set, and you do the same thing on the connecting rods. Well, except for, you know, you use the Torx for the connecting rods, not the ones for the main bearings. And that'll get you within a range, and it'll get you pretty close, so you'll know roughly how much clearances you have. I'm going to show you with very cheap tools the other way to measure all your clearances, because as you start making more horsepower, all those clearances become very, very important.
So for my hot rod, it's not quite as important, the clearances?
Depends on what you're going to do. Right, so on a hot rod, if you're just going to go out and use it to cruise, you want it a little bit loose. If it's your daily driver, you want it a little more tight, because those bearings are going to wear, and the gaps are going to start opening up. And that's what happens. As those gaps start opening up, more oil is able to seep out. So if you're just going to go, you know, horse around a little bit here and there, you want a slightly larger bearing clearance. I'll explain, you know, according to basically how much horsepower you're looking to make, what numbers you're looking for.
And that'll be in the reassembly video.
Yeah. When they'll be in the reassembly video. As we're doing the bearings, I'll go through on how much clearances you should have as we're reassembling that part of the motor. Now, why don't you get out in the garage and do something?